Flavor and aroma are what make every beer or wine stand out. But if you want to control them, you first need to measure them. In this video, I'll take you through how to profile flavor compounds with gas chromatography, step by step, so you can see just how simple it really is. But before we run any samples, we need flavor standards. These are compounds like esters and aldehydes diluted to known levels. This is so the GC has some reference points. We're going to start with a strong stock at 1,000 parts per million. From that, we're going to step down each one, 1 to 9, each time to make 100, 10, 1, and 0.1 ppm. Now we're going to fill in the in-between points. 5 ppm by mixing half and half from the 10, 0.5 ppm by having the 1, 0.05 ppm by having that 0.1, and finally 0.01 ppm by one more 1 to 9 step down from that 0.1. By the end, you'll have a neat ladder of flavor standards from 0.01 to 100 ppm. This is the range you'd expect to see in beer and wine. Make sure you put each solution into its own clean, clearly labeled vial. Use a fresh pipette tip every time. Make every dilution in a fresh container, and do not pour anything back into the stock. Once it's out, it stays out. Now for the sample, this part's easy. You're gonna open it up and get rid of the bubbles by pouring it back and forth between 2 flasks until the foam settles down. This is called degassing, and it stops the CO2 from messing up the injection when it goes into the GC. Now, if your beer or cider is really cloudy, you can also give it a quick filter, but most of the time degassing is all you need. After degassing, you're going to take a small amount, transfer it into a clean vial, cap it, and that's it. Because this is a direct injection, there are no chemicals or extractions. It's literally just your drink going straight into the GC. So what's happening inside that GC? Well, gas chromatography is just a way of separating compounds. The injector heats the sample up, which turns it into a vapor. This is carried through into a column inside the oven. The ethanol comes out strongly, but so do the trace flavor compounds, each at different times. For this method, the oven starts at 50 degrees C and gradually ramps up to 220 degrees C. The injector is set at 250 degrees C with a short splitless period. Hydrogen is used as the carrier gas under program pressure, and detection is by FID, or flame ionization detector. Because ethanol is at such a high concentration, the GC uses range switching during the ethanol peak. That way, the trace flavor compounds, which may be 1,000 times lower, still show up clearly in the sample run. Now that the method is set, it's time to calibrate. This is where we teach the GC what the different levels of each flavor compound looks like. You're going to load your standards into the auto sampler and run them, from lowest concentration to highest concentration. Now, if you don't have an auto sampler, you can inject them manually with a syringe. You'll drop around 1 microliter of each and inject it into the inlet and start the run. Now, each standard gives a peak, and the software plots that peak size against the concentration. The result is a calibration curve for each compound. These curves are your rulers. They let the GC turn a peak into a concentration. Now that the GC's been calibrated, you're going to place your beer into the auto sampler or inject it by hand with a syringe. The GC does the rest. As the run goes on, ethanol appears as a large peak, while the esters, aldehydes, and higher alcohols appear as smaller peaks around it. Thanks to that calibration we did, the software can measure these peaks and calculate the actual concentration of each compound. When the run is complete, you'll have a chromatogram showing clear peaks for each flavor compound. By comparing them to the calibration curves, the GC gives you the concentration of each one, the esters, the aldehydes, the higher alcohols, and anything else you're testing for. Having this profile is powerful. It helps brewers keep flavors consistent from batch to batch. You can highlight desirable aromas or spot potential off flavors early. So you saw the workflow for this is really simple. You make your standards, prepare your sample, calibrate the GC, run the beer. In a single analysis, you can capture the compounds that define your flavor and aroma. Flavor profiling is just one way that gas chromatography can be used in brewing. This same approach can also test alcohol content, track off flavors like diacetyl, or even monitor nitrosamine. As you saw, flavor testing isn't complicated. Once you've seen the steps, it's quick, repeatable, and very practical to bring in-house. And if you found this video useful, please give it a like and subscribe for more. And let us know what other analysis you'd like to see us do. Thanks for watching.